Good afternoon to all the participants. I will introduce, Whirlpool is participating actually in two of the project of 4C cluster, SERENA and UPTIME. I will concentrate this presentation on SERENA, but also would like to spend 2 or 3 minutes talking about UPTIME. So let's start with what is SERENA. Of course, is an Horizon 2020 project, as it is in all the 4C cluster. It's led by Comau with the project management done by LMS. And first, it's putting together some technological company, some ICT-based company, and also some company which are just there to provide some interesting use case. Whirlpool, of course, is one of them. We are providing a use case that I will be showing afterwards, which is the main objective of SERENA. As Cosmas was saying, the principle is actually to provide a platform which is versatile, which is transferable, which is scalable up, which allows, of course, to put together all the basic functionality of a predictive maintenance. So the idea is, of course, that those platform has to be flexible enough and cheap enough to be used in the future by a potential and the high amount of number of potential customers. How does that? Of course, by trying to using as much as possible open source component and available software. Let's get into the details of Whirlpool use case. Our case is based in a factory we have here in Italy, close to Varese, where we are producing built-in refrigerators. One of the core process of built-in, old refrigerators is actually the action of filling the small cavities between the inner liner of a refrigerator and the outer part with a polyurethane foam. This is the basic function of keeping the hot outside, or if you want, to keeping the cold inside the refrigerator. This plant is very complex. It's a complex equipment which is putting together some chemicals. So we are mixing together polyol with another component which is MDF. We have to premix them. We have to, of course, dosing currently the two parts, and then the two parts are mixed together at the very last part in what is called the mixing head. And we will see in the future how and why this is the core of our use case. Important for Whirlpool, and I think also for the audience, is the fact that our approach in predictive maintenance is not an island, but has to be embedded in our professional maintenance pillar. What is professional maintenance is one of the pillars of world-class manufacturing. World-class manufacturing is a continuous improvement methodology that has been strongly based on lean manufacturing, and the professional maintenance pillar is actually foreseeing that when during the maturity level a plant or an equipment or a department is want to achieve the excellence, in which the step 7, the maintenance cost management, is established, and there is a complete management system. You can see at step 7 there is a build a predictive maintenance system, or CBM, condition-based management, if you want, even though for some scholars those are a little bit different. So of course this means that for us we are in those projects try to learn how to be prepared to arrive to step 7 with all our equipment. So talking about the foaming system, as I said, is a very complex plant. It's a complex equipment, a lot of different parts, which to concentrate on. Of course, we cannot monitor and do predictive maintenance on all the parts. When we run the FMECA, it turns out that the most critical part of this machine is the mixing head. The mixing head is where the two components are mixed together. It's a very critical one, and of course, as you can see, the breakdowns are 85% of the all breakdowns are concentrated on the mixing head. Moreover, the cost of replacing and refurbishing those mixing heads is pretty high, so it costs a lot. That's why we decided to concentrate all our effort on the mixing head. Fortunately, the system that we have selected as a use case was already equipped with a SCADA system. So we had already a proprietary system that were able to measure and take monitoring of some of the parameters of the two components, in this case, pressure, temperature, and the flow of the, in yellow, you can see the polyol and the other components in red. And we had also the opportunity to use the project to install a new prototype sensor head that have some mechanical sensor embedded in it. So those are all the components, all the sensors that they are going to use for our prediction. Since we had already a production monitoring system in place, what we did to prepare our use case for the experimentation within SERENA was to extract all those data to an SQL database that has been provided to the SERENA platform. Since this seminar is mostly related to microservice architecture, I will try to step directly into the architecture. This picture has been already shown by Cosmas. So the main architecture, as you can see, is based on an open source component, and there are also in the architecture base some of component that has to be run in the cloud and some other that has to be run in the premises. In principle, in the premises, so close to the concept of edge computing, there are some pre-processing rules or some very easy data transfer, data computation, and so on. And then all the important part, the most like persistence or the scheduling, the predictive analytics, those that are requiring more computing power, has to be deployed and delivered in the cloud. In this case, the plant machinery level is exactly the shop floor level, so where our machine is providing the data. In our cloud service, those are the components that has been deployed. So NiFi is a system mediator. Of course, we are using, I don't know, of course, but I know that is one of the most important one when talking about big data, is Hadoop for clusterized the data store. As also Cosmos were accessing, we decided to use a Mimosa data structure, so to adapt and to use the Mimosa standard since the beginning. So all the data has been modeled and all the situation has been modeled using Mimosa. On the right, we have the data analytic frameworks, which is running on the Spark under Apache, that is used for model building and to make the prediction. The prediction is actually used to define and to estimate the remaining useful life. Then we have two important parts, which are a scheduler that will be used to define the order of maintenance. So where and when I need to do some maintenance order provided by the remaining useful life. And also we have a part which is dealing with visualization and with the help of the maintenance using augmented reality. The system, of course, has provided also a platform, a dashboard for providing the user interface. This is a single point of entrance for all the functions. So, of course, we can access to the prediction, measurement, and also the factory alarms. We have also access to the maintenance plan, and that's quite important. We have also access to the metadata. So the model of the data can be accessed through the platform, and so there is not a different way to access the metadata and to manipulate them. Is of course very responsive and allows for multi-device support. Now let's understand how Whirlpool interfaced with that. As said, in the premises, we have our system, which is providing all the data, the sensor, and always on premises, we decided to decouple the production system. Of course, we are talking about a machine which is in production, is not a prototype, is not on a separate state. It is producing daily refrigerators. And so we decided to decouple the analytical part and the experimentation part through an SQL server. So all those data are charged and loaded in a SQL server, and then through a gateway. The gateway could be both hardware or software. In this case, has been deployed in a software with some pre-processing rules and some functionalities, is sent over a transport layer system through the SERENA platform in the cloud. Here, the predictive analytics engine is runs to provide the remaining useful life estimation that will be then used by scheduling, and the scheduling could be then captured by the augmented reality system that has been provided through Oculavis. Oculavis, our AR partner, is providing both a platform and using some glasses that could be used by plant operator to be instructed on when and how to do the system maintenance. So this is a much more detailed description of our testbed. As I said, on the left side, you can see all the things that are on premises. So we have an existing SCADA system, an existing factory SQL database that has been fed with all the data coming from the sensor. Not yet integrated, but could be integrated in the future. We are also providing, especially for the learning phase, for the machine learning phase, some other data, for example, breakdowns, repair time, some extraction from our CMS system, which is based on SAP PM. And all those data are then connected through a VPN to the cloud, where all the specific activities are done. Let me just spend a couple of minutes on how we use the data and how we are able to provide some prediction on that. The data is pre-processed, and then there are a supervised learning. So all the data has been somehow labeled and connected with the events. In particular, we have some alarms coming from the system that are very important for us. So the system is able to detect a specific self-cleaning piston not open, which is an hardware alarm that the machine is providing. Is a not blocking alarm, of course, because by just making some adjustment, the machine starts working again. But the system, the analytical part, provided to us a very interesting insight, because those alarms has been always related with some increasing on some signals coming from the accelerometer placed into the machine, the injection head. So this is allowing us to anticipate the presence of the self-cleaning piston, of course, statistically, because we applied to all those data different algorithms, and we were able to find, thanks to Polytechnic of Turin in this case, we were able to find out the best algorithm which is fitting the current data we have. So having this capability of predicting with some days in advance, that's exactly what we need. We don't need to have a prediction of minutes, because there is no, no use. It's not useful to have some information, such information, in minutes. We need to have it some days before. It gives us all the opportunity to arrange the maintenance, to schedule their work, to provide the parts, and so on. With this information, we can see that there are already some estimated very interesting positive impact. Why? Because, of course, we can avoid all the hours stopped for substituting the head. So the head can be substituted only in planned period in which the machine maybe is not working. And so for sure we can avoid to have some breakdown that are impacting the OEE. Since also the MTTR is now, it's depend if you want to calculate MTTR as in terms of real hours or impacted hours. In this case, since MTTR is something that can be done during a typical for planned maintenance, is not a repair, actually, it's just a substitution. So also the MTTR is reduced. The MTBF, since we think that we are able to avoid at least one of the negative events that historical occurs during the year, we can see that we can double the MTBF from 106 months to 1 year. And also the total cost of maintenance has been reduced because, once again, the cost of reconditioning head, which is the most important part of the cost, because the head are not substituted completely, they are very costly, they're very expensive. So usually what we do is to disassemble the old head, send it to our supplier, which is reconditioning it. It does do some machining on it and so on. By anticipating a lot the wearing of the head, we are foreseeing that the cost of repairing them will be lowered for almost a half. Of course, this is the business impact from one side. The return on investment is not yet available because we don't know commercially how the system could cost to Whirlpool. But in any case, the indication is that the system will be very, very, at least providing a lot of impact, that's for sure. Now, let me just spend a couple of words about the uptime use case. Completely different factory. We are here in Łódź, in Poland, where we have a dryer factory. Also here, the case is based on a very complex machine. It's an automatic line for producing the drum of a clothes dryer. It has making everything automatically, starting from a coil of stainless steel and ending with a complete drum, which is made by 3 different parts of stainless steel that, of course, has been processed during all those stages. Very complex part. Also here, we had the chance to use some existing sensor and to install some new sensors. So we had also here a very high variety of data that has been used to also, in this case, make a prediction. For what is regarding the architecture, you see already this picture. So the idea, maybe it's a little slightly bit different from SERENA, was to make modular the system based on the functionality. So we have a sense module, detect module, a predict module that can be somehow interface one each other in order to define the best solution for the final consumer. From the technical view, also the uptime architecture has been somehow divided and grouped into the REMI 4.0. So we have a business layer which has deal with the user interaction visualization, and a functional layer, which is the one that has to do with the decision making. and all the part of analytics. And then we have the information communication layer that has to do with the integration with the shop floor. If you are interested, there are, besides the third seminar of 4C cluster, which is going to take place in November, there is also available in the website that you can see here, previous presentation of the Whirlpool use case inside UPTIME, and so you can have access to it. There are a couple of videos you can for sure see. Let me conclude my speech, last minutes, what we learned. I said, now I focus only on the technical side. So there are a lot of, in my opinion, a business and organizational learning, but it's not that the moment to talk about them. So first of all the predictive maintenance architecture needs somehow to be integrated with the existing legacy system. So that's especially true for large company. We have already an existing MES, existing SCADA, we have maybe existing ERP, and so we need to find out a way to make sure that those architectures has to be somehow easily integrated into legacy system. Otherwise, it becomes more difficult to adapt them, to use them, and to make them a valuable and viable economical system. Of course, also the choice between edge and cloud is not always that easy to do. Cloud costs sometimes are transparent, sometimes are not. So also the scalability to decide where to put the edge and where to put the cloud could be clearly helped by the architecture itself. The openness to new analytical algorithms and the machine learning approach is another important part. There are many different techniques, many different available algorithms, and I think it's very important to have this openness and to make sure that as soon as the technology or the methodology behind evolve, we can try and insert this new part. Then the last part, the only comment I do on the soft side of PM, of course, what we learned is that data scientists and process sector very often are not speaking the same language. So it is very difficult for them to understand each other, and it takes a lot of time and effort to for the data scientists to learn about how the process is working, and for the process expert to understand what the data scientists are trying to do and which kind of questions they are doing. The other things also highlighted by Cosmas, the point of skill gap in maintenance operator. Maintenance operator very often are not yet equipped with the basic education dealing with the complex data and so on. And more than that, we need to earn their trust. So it's very important that all those projects dedicate a lot of effort in making sure that the prediction is accepted and trusted by the final operator. Otherwise, the risk is that we are producing just false alarm or false negatives, and that's of course is putting at risk all the PM project. With that, sorry for taking some minutes more. I'm finished, so I step back and give the floor to Giulia